Imagine a world where music is not just a static composition, but a dynamic and interactive experience, where every note, every beat, and every expression can be precisely controlled and manipulated with the flick of a digital switch. Welcome to the captivating realm of MIDI data, where the language of music transcends traditional boundaries and enters a realm of limitless possibilities. A common issue nowadays is getting a MIDI file for music. If the song is not popular, the odds that you find a correct MIDI file for it are slim to none. Our project is the first important step in alleviating that issue with deep learning AI models. Through crowdsourcing MIDI and its audio from musicians, we can create a dataset that will allow AI to recreate MIDI files from just hearing the raw audio. This is the demonstration video for Midi Performance data, an open source solution for recording and accessing audio and symbolic music data all on one website. To get started, we're going to meet the team. There is Scott, Mason, myself, and Professor Patrick Donnelly. Scott was a front-end developer on this project. He was in charge of the search functionality of our website. He also was responsible for part of the pipeline to query data from our database when users are trying to use our search function. Mason was the mainly working on the recording portion of our website. He was also our MIDI specialist and was able to work on taking audio files and converting them into MIDI data that I was then able to use later. I was in charge of our backend and our cloud database. Basically, I was in charge of creating the pipeline to take the data that Mason is creating and then store it in our Firebase cloud database. And I was also in charge of just managing that database and making sure that the data was all stored in an easy format for us to then pull and use at later times. Patrick was our project partner. He was the one who started the idea, and yeah, we'll get into this here.
Our Capstone project sets out to be part of the solution for the task of automatic audio to MIDI transcription. Two major ways that sound can be digitally stored is 1, as a raw audio bit stream, or 2, as discrete on and off musical events. The former is the most widely used across digital audio today, where we listen to music as audio bit streams on our phones, and musicians record their performances in the same format, capturing the actual audio itself. As convenient as it is, though, you can't go in and read a specific note in raw audio, nor can you go in and easily change that note. Raw audio also cannot be easily transcribed to sheet music, since again, we can't easily extract the discrete notes and their details, such as pitch, length, and instrument type. That's where the second format of audio storage comes into play, though. MIDI, or Musical Instrument Digital Interface, is a digital audio standard from the 1980s that instead captures these details as musical events, and then relies on the playback device's sound card to act upon these events. Since MIDI stores discrete notes, it can be easily edited, and best of all, can be easily made into sheet music and other accessible formats that can be processed a lot easier by software applications. However, the issue is that most of our audio today is stored in the first format, whereas the second format has some desirable traits that we'd like to have. If there was a way to convert the raw audio bit streams into MIDI, though, we could have the best of both worlds. Luckily for us, it's possible by utilizing large machine learning models, but the issue with making those is that they need a lot of data to train on. In order to be accurate, they'd need to see a lot of examples of music that's stored in both a raw bit stream and in MIDI synchronously, so we can make relations between the two within the model. And that is where our Capstone project, the Midi Performance data website, comes into play to solve this problem. Over the past 9 months, we've set out to develop a website where users can both contribute to a database for training these machine learning models, as well as access this crowdsourced database to acquire the data necessary for this model training. The website would need to have both a recording interface for the first part and a kind of data search page for the second. For the recording page, a user would need to be able to connect a microphone and a MIDI-enabled digital instrument that would be recognized by the website. They'd then have to be able to record a musical performance on the website, where said website would then record both the raw audio bit stream through the microphone, as well as the MIDI events via the MIDI output stream of the digital instrument. These synchronized audio files would then need to be submitted in tandem to the website's database as a single entry. As for the data search page, a user would need to be able to both find and consume entries from the database. They'd not only need to be able to see all the data entries at once, but also make specific search queries for songs, such as from specific composers or songs using specific instruments. They would then need to be able to download these data entries as clean and organized zip files for ease of later use. Now at the end of our Capstone project development, we've been able to successfully meet all of these requirements and put them together into one final web application product. And now we'll go ahead and demonstrate how each part of the web application works. So now we'll take a look at the search page of the MIDI and audio performance data website. So as you can see, we can navigate to search just by going up to here, and right off the bat you'll see we get a full query of all the current entries that are inside the database. And this way the user can just instantly see the whole query and then download the results and just have the entire database for their own usage. And we can just do that right now. I can click download result zip, and you'll see we get an audio zip file and a MIDI zip file, and each of these have the corresponding audio and MIDI audio file entries inside them. And as you can see here, we have individual song entry cards for all our entries, and on them you can see we have title, composer, we have a MIDI player here which actually live plays the MIDI file using the user's device sound card. We can access the MIDI file and audio file and also see the instruments used, and if we click on audio file it will pop up a web audio player to hear the actual recorded audio file. So before I show off search functionality, let's just go through and do that. So you can see we have MIDI and audio player, so I'll start here by playing MIDI, and as you can see we will hear the actual MIDI file be played by the browser. And then we can see if we click audio, we'll get the exact same file, but instead with its audio format versus MIDI. So you'll actually be able to hear the live recording. And these are both from the exact same performance, just one was the MIDI stream coming in from the MIDI instrument, whereas the other was the actual audio being picked up by the microphone recording the instrument being played. And now we'll go ahead and look at the search functionality. So as you can see, we can search by title, composer, and instrument. These only work once at a time, just because we can get the data we need that way. So we can start here, we can go title, let's go Snowbell, since that's one we just played. Search by title, we get this right here, we see our song query title. We can download the same result zip, but it's only going to contain this one entry since that's all that popped up. And it's all interactable in the same way. And now by composer, let's do Handel Halverson, which should pull up Passacaglia. And there we go, and we can see it's a composer query this time instead. And then lastly, we'll go by instrument used, which can be seen down here, and this should pull up, let's see, Nord, Grand MIDI. This should pull up a multi-result query here. And you can see we get all the things that use Nord Grand MIDI, which again is actually all of them because that's what we have in the database at this moment. And we can download a result zip of that too. And with that, the user can very effectively consume all the data that we find in the database for the MIDI data. Thank you.
Up next is the recording process. This includes 3 pages in total: input selection, recording, and labeling/upload. These pages are responsible for recording user input across multiple MIDI devices, recording audio from the connected microphone, getting metadata about the recorded submission, and finally uploading the completed submission to the backend and database. When we were designing these pages, we wanted first and foremost to keep the process as simple as possible for all users. With this came some specific goals. The first was to prioritize ease of use. This meant commonly used actions needed to be fast and simple. Users should be guided to resolve possible and common errors, and users need to receive immediate and obvious feedback upon performing an action. The second goal was for the interface to be intuitive and friendly. In this case, we use our web app's spacing and layout to make interactions feel predictable and familiar to even a first-time user. The third and final goal was to minimize the required user interaction. This goal is mainly a supporting idea of the first two, but through designing for minimal required user interaction, we are pushed to create an interface that is easy to use and intuitive. Throughout the demo, I'll point out examples of where these goals were applied in the interface's design. From our homepage, we can access the recording section of our app from the top navbar. I'll just go ahead and click record up here. And over here, we can see this is our input selection page. We have two separate sides, our unselected and our selected. And here is my MIDI keyboard that is currently plugged into my computer. I can move this over to the selected by clicking the arrow over here, and we can see that it moves over to the selected section. If there are no devices detected, the app will prompt the user at the bottom, and I can demonstrate that by unplugging my keyboard and reloading the page. I'm currently using the Firefox browser to demonstrate another part of our user-friendly design. We have some small help text here that says, if you don't see your devices, try refreshing the page. So if you plug in your device and refresh the page, your web browser will refresh and detect any new devices that are plugged in. Since I'm using Firefox, we see a little tip here that says it looks like you're using Firefox. Sometimes Firefox will prevent us from connecting to MIDI devices if they were connected after the browser has started. Try restarting the browser with your MIDI devices already connected. So we can alleviate a common issue that people would have with our web app should they be using the Firefox browser. And this does not show up on the Chrome browser, for example. Now I can just go ahead and refresh my page after plugging back in my MIDI input. And here it is again. Moving over to selected, I can confirm my selections and move on to the recording page. Over here, we keep buttons as simple as possible. There's only two interactions that we have here. We can start our recording or head back. We also have our timer here that shows how long we've been recording for. And when I go ahead and click the record button, it will ask me for access to my microphone, and I can allow that. And we see that the timer begins to increase and the button has changed to a stop symbol instead of the record symbol. Additionally, there is now a red border around the edge of our screen. The website is now recording our inputs, and any inputs that we play on our keyboard will be recorded, tracked, and then once we click stop here, are now stored, and we can put in our session name. We'll have this as our test. Please delete, since I don't want to be clogging up our backend database, and we'll have our author as developer. Once I click submit here, we'll see a pause as the recording is updated and uploaded, and we'll have a small alert from the website that says that our recording was submitted successfully, and it now appears in our backend. And that's it for our recording demo. And now we'll be moving on to our backend demonstration.
So here in our database, you can see that we have a collection. We actually use the MIDI collection is just for tests, but whenever you actually use our web page, things will be stored in the sessions collection. You can create a session name. For example, we'll do the dancer here. Whenever you store the data, it'll be stored with an audio URL. You can get the author of it. It'll explain what MIDI devices were used. Then you can also get a MIDI URL and then also the session name. And then looking in our actual storage, you will see inside sessions, there's audio files, and then there's also a spot for all the MIDI files. And then this is so makes it easier for users to be able to download their files later. And then we also have all of our hosting information here as well. As of right now, our app is hosted through Firebase, and in the future, I think we will move that to AWS.
Overall, we are satisfied with the progress the application has made over the course of the term. However, there are still stretch goals left over from the planning stages of the project that we did not get to, but there are plans for the next group taking over this project to work on them. The first would be to be completed, most likely would be migrating the system from Google Firebase to Amazon Web Services. Firebase greatly sped up the development process for our group, but our project partner, Dr. Donnelly, would prefer to have all of his applications on one unified service. It would also make it easier for our application to be part of the official Soundbender website instead of having its own dedicated site. The next would be multiple microphone support. The web API we used for audio recording currently prefers to connect only one single microphone, so this would be a complicated undertaking for the next group, as the code would likely have to be much lower level than what we are currently doing. This would allow for each MIDI device to have its own dedicated audio file, instead of one MIDI file for a single audio file. This project is quite flexible and can be taken in any number of directions, and we look forward to seeing the next iteration of this project and the research that comes from it. Thank you so much for listening.